Hey there, how you doing? Good to see you again. Chapter 2.4 is going to be our section for today, and we're going to talk about chemical reactions. We alluded to a little bit of chemical reactions last time. We're going to break down the anatomy and the parts of a chemical reaction. So here we have some iron. Some of you are familiar with this. This is rust. When you leave iron exposed to the air long enough, it'll react with oxygen, called a oxidation reduction reaction. We'll talk about that much later this year. But rust forms, and you have a chemical change in the iron. The iron chemically changes to iron oxide, which is called rust. And it's an irreversible change. That's called a chemical change. So we're going to talk about chemical changes today. And how do we know if a chemical change has happened? Okay. What always happens during a chemical change? So chemical changes are based on one thing called a chemical property or chemical properties. Okay. And so these chemical properties are observed when the substance undergoes change. So last time I was talking about how sodium reacts when you put it in water. It looks like a firework with all these sparks. And that chlorine is this gas that when it reacts with your body, or it'll kill you. Okay. Or it hopefully in a good way kills the harmful bacteria and things like that that might grow in a pool that we don't want to grow in there. Okay. So these chemical properties help us understand that a chemical reaction has happened. So the chemical change, the composition of matter always changes. That's what you have to know. In a chemical change, the matter has changed. Okay. In a physical change, the matter hasn't changed. It's still the same. It's still the same material. It's still same composition or elemental composition, but it hasn't changed. So if I take a rock and I break it, it's still made of those same components, those elements and minerals. It hasn't changed. Okay. But in a chemical change, like the rust, like the right there, like that steel chain, it's made of carbon and iron. That iron has reacted with the oxygen in the air and has changed forever. Okay. So that's one thing you need to know. Chemical property, chemical change, the matter changes. In a physical change, the matter doesn't change. Okay. So for instance, here we have a magnet separates iron from sulfur. This is an example of physical change. You remove the iron from the sulfur because iron is magnetic and sulfur is not. The iron or sulfur, they didn't change, okay? But if I take that same iron and that same sulfur and they're together and I heat them up, they will form a chemical reaction called iron sulfide. And that iron and sulfur are now chemically bonded together, forever changed, okay? So here in this example, the iron and the sulfur were separate. Okay, we could separate them. Now that we've added some heat, we've induced a chemical reaction, and that iron sulfide the iron is forever bonded to the sulfur. So this is an example of a chemical change. Okay, so we'll talk about a little bit of the anatomy of a chemical reaction. A chemical reaction is just a way of writing what's happening. So the reactants are the products, or excuse me, reactant are the compounds or the elements or the mixtures or the substances that are doing all the reacting. They're the ones getting together, exchanging electrons, giving away electrons, those types of things. That is a reactant. Those are the troublemakers, if you will. Okay. The substance that is produced from that reaction is called the product. Okay, it's called the product. Okay. So there are 4 clues. I want you to think about those for a second as I say them. 4 clues that'll tell you that a chemical reaction or a chemical change has taken place. So think about all the chemical reactions you've seen in your life, from science classes to you've eaten some food, or you might see something, you might see a fire happening or something like that. What are some clues that a chemical reaction or chemical change has taken place? Think about that for a moment. Even pause the video if you want to pause just for a moment. Now, those would be this right here, the transfer of energy, meaning that something's getting hotter or something's getting colder. Okay, something's getting hotter or something's getting colder. Okay, you might see a color change suddenly when you added one liquid into another liquid. They were both clear and now they're yellow. Okay, so there was something happened there. There was a production of gas. You saw bubbles come up. Okay, so the vinegar and baking soda example. Okay, you know that if something's happened when you put vinegar and baking soda together, the reactions happen because you see a gas form. Okay, another one with that in the baking soda vinegar reaction is that you see a transfer of energy. The container, the resulting liquid that's there, the vinegar part, will get colder. That's another way that you can tell. Another thing called a formation of a precipitate, a solid form. You had two liquids, you mix them together, and suddenly there's some solids forming in the bottom of your beaker or the container that you're using. So it doesn't have to be all four of these, but it needs to be at least one of these. Several times you might see at least something. You might see two or three, or maybe all of them that you might see those. Okay. So a precipitate is a solid that forms and settles out. And that's a clue to some of these applications. So, for instance, here at pH, you might see a color change, but if you see a chemical reaction happening when you make cheese, this is cheese curds being made, or if you're pouring those in there, that's how you can see if a chemical reaction has occurred. Now, in a chemical reaction, the mass of the reactions always equal the mass of the products. The left side of the equation always equals the right side of the equation. So during a chemical reaction, the mass of the products always equal the reactants, and the reactants always equal the products. We'll have entire chapters on this right here, and we balance chemical equations later. So that's called the law of conservation of mass. It says that physical changes or chemical reactions, mass is conserved. You can't make more mass or you can't lose that mass. So if it happens in a closed container, you'll see the same mass before as after. So let's go back to the vinegar and baking soda example. If I weighed my baking soda and I weighed my vinegar beforehand and I weighed the containers I was using in theory, if I put those two together and I see some bubbling happening, it should weigh the same. It won't, but it should weigh the same. The reason it doesn't weigh the same is that gas has escaped. So if you maybe put a balloon over that container, some way to contain the gas that's formed, if you weigh the gas, I'm sorry, you weigh the baking soda and the vinegar and all your containers beforehand, including your balloon, weigh it all, and then you weigh it when you're all done and you save that gas into a balloon. You'd weigh your beaker of the liquid that has now formed with the vinegar and the baking soda. They should weigh exactly the same. So here's a picture of that, or an example of that. You have these two clear liquids, and those two clear liquids have a mass of 43.43 grams. You take this vial and you pour it into that vial. They both have their caps on, so it's a closed environment. So even though this one, it's empty now, it's been poured into this one, it is now still 43.4. Now, a chemical reaction has occurred because you see a color change there, clear, and now it's kind of this orange juice color. Okay, so conservation of mass is conserved. Okay, so the main thing I want you to know is conservation of mass, and that these right here, these four different clues: energy change, change of color, production of gas bubbles, and forming of a precipitate or a solid. So that's it for this lesson, and I'll see you soon. Bye.